I am starting the recording now. Hello everyone watching this at a later point in time. And so for today we're going to be looking at what is called the Sandboxed AI. How to run it locally, how to run it with a connection to external vendors, how to run it in a dangerous, unsafe way, how to run it in a slightly more safe way, but still maybe a bit unsafe. So I guess we can ask a little question from the audience. Is there anyone running Sandboxed agents at the moment, actually, right? So it's not just going to Claude, but actually having something like Claude Code, Open Code, something like this. Is there anyone that has this? Or anyone that's curious about this, that wanted to try it before? Or is the idea of this completely new to everyone here? I don't believe that's true. No local LLMs. Right, so those in the watching this back will not be able to see the chat, so I will essentially reiterate if there are questions or responses. I will mention them, so don't be afraid to speak up. Yeah, so people are saying that they're not running their own LLM locally because it's already too warm, and it's exactly the same for us, right? So on the other hand, in winter it's quite good, right? So there we go. We're saving a little bit on the energy bill by well, maybe not saving on the energy bill, but at least we don't need to also add cooling on top of it. So we have, now I'm setting up a local LLM, and it actually is quite easy to do, right? If you remember where we were left off last time, right? We were using Gemma 4. Ooh, there's a kitten. The cat is yowling at the back. Most of the power for a PC goes into heat. Yeah, it's actually just like a heating system. It's just my central heating system. The compute is a side effect. Can I get this maybe dark mode? Can I get this dark mode? I don't know. Quite sure there is a way to get that dark mode. Interface. Chat. Must have scrolled past it, no? Well, whatever. It's fine. So last time we were leaving off at this local hosted open web UI, right? So here you can essentially chat with your LLM, so whatever one you like, and you can also control the system prompt, and you can control parameters like top K, top P from here, which is nice because then you have like one unified interface for all kinds of different LLMs, right? So you can actually also connect external vendors with this, which we did last time. You can actually add a lot here, like knowledge bases. So you can add documents here, you can add websites here for like a sort of RAG setup, right? So this allows you to kind of prototype your LLM and RAG system. It's not like, of course, an end-to-end solution. This is local at the moment. And even if you would expose this, it's not really meant to be exposed, right? Like this is essentially just a way for you to prototype nicely whether the current model, the current knowledge base is appropriate to use maybe in some final system, and then you can try to integrate it into maybe a website that you have or something else, right? So this is kind of where we left off last time. So we can just check to see if our connection is correct. Yeah, tell me a fun fact about the Roman Empire. That's very, very good. You can be fun. Let's see if they can be fun. Ooh, it's taking a while. There we go. It's thinking, right? And so this is interesting. One of the things is that you can inspect quite a few things because if we're hosting everything ourselves, you can in principle see and inspect exactly what's being sent off, including the system prompt to the actual LLM, right? Which is very often hidden from you. There we go. And they have... they are thinking about a lot of good ideas already, right? So we can inspect that now, and so we get a little bit of an idea what it's thinking, but I should note that none of this is necessarily really going to be informing its output. It is as if you're grounding it in this, right? So it is as if maybe you had written this before, and so it can take from this, it can take from this information, but it may also just hallucinate something else entirely unrelated to the thinking. And LLMs are known to do that actually in cases where they have very strong biases, right? So if this is an LLM with an unfortunately very strong racial bias, for example, even though maybe its reasoning, its internal thinking may be much more nuanced and much less biased, in its output it can still have many, not just implicit, also very explicit biases sometimes. So it's good to know that the thinking is more of a way for it to self-ground, but even then, how sensitive it is to grounding is not 100%, right? So there we go. That's a little bit on LLMs, which is important to keep in mind because, of course, everything that we're going to be doing today and everything that we're doing in this entire series is using LLMs as the backbone. And as I have repeated a few times now, but it's so fundamental, I think, that it bears repeating a few more times. These LLM systems, the agentic AI, the chatbots, ChatGPT, they are modifications of the LLM, right? So they may be fine-tuned, and then they are modifying the input through, for example, adding an extra system prompt, changing how they sample the LLM's output predictions, adding more information to the input through RAG. In this case, even allowing it to kind of self-ground with being instructed to first output what we call thinking tokens, but they are really just essentially the same. It's been trained to output them a little bit differently, but still they are in effect very similar to just regular outputs, of course. And all of this essentially modifies then the input for what the model will write when it actually is time to write this very first output, right? Then when it's time to actually do this, it will sample based on the settings, and in the case of structured output, which maybe I'll touch on later, in the case of structured output, you can even directly modify which logits or which, let's say, outputs you accept, right? So if you want to always start a sentence with meowdy, then with structured output, you can actually do that, right? So then you essentially force the LLM to always say meowdy as its very first word. So that's on the output side, right? So in essence, all that we're doing here is we're doing modifying the input and output when we're building systems with these LLMs. And finally, when we have the output, we can also tell the model, we can train the model that when it gives a specific keyword, right? Like, for example, when it says search, right? Search, colon, that instead of having the LLM continue from there, instead we will take whatever it is trying to search for, we will actually put it into Google for ourselves, or well, I mean, it's automated, right? It's happening behind the scenes. Then the search results are returned, and then it's told to continue answering based on those search results, right? So actually, tool use is really just some extra system that's being added on top of the output of the LLM, right? So this is why I'm saying it's like a really core idea. And then agentic AI is a way. So as I explained in Excalidraw last time, I don't think it's still open. No, I don't think it's still open. But if you have this nice LLM system, LLM, and normally it gives you an output. It takes an input and then it gives an output to the user. When we're allowing it to do some thinking, right? In this case, the thinking kind of goes here, and it's autoregressive, right? So it means that whatever it outputs goes back alongside the previous input, and then finally it gives some output, right? So this is kind of what our thinking LLM is like. But maybe actually before we actually give the output, we want to put a little bit of a classifier, right? So it's like a classifier. It's like maybe also another LLM, which just makes sure that the output is safe or not, right? So like if it's not safe, it will basically go back and it will instruct the LLM to do it again, but then now to not use so many swear words or not to be so explicit, right? And then when it comes back to the classifier, and okay, now it is actually good, so then it goes to the user, right? Basically. But we can do, if we add a classifier that is a little LLM, right? So it's like a tiny LLM, so LLM, it's very small. Instead of actually just having that there, we could have an entire system of little things that send it off. So maybe here is another one. And then maybe here we have another one. Maybe here we have another LLM. And these all maybe do different things. Sometimes they come back. And that's it, right? So maybe one is instructed or is like a larger model, right? So this is like a larger one. And so these are maybe smaller ones that are very specific for a certain thing, right? So this one just tells the user, no, don't ask that. This one just maybe summarizes what this one was saying, and then it goes back into the final output, right? So we have now a whole system of LLMs that get called at different times, and this is basically like some agentified workflow, right? So this way you can construct interactions between LLMs, and they can be recursive as you like. So maybe this is maybe a topic for the next time. It seemed there were some people that were interested in agentic RAG, right? So this is when we are retrieving a set of documents, right? So we have some documents, a lot of documents, and normally we can only get the top ones from an input query, right? So we have an input question, and these are the best ones. But actually, if we have agentic RAG, we can also get an agent to reformulate this, right? So maybe they can rephrase this so that more relevant documents are retrieved. So this is new documents that are retrieved based on the other user query. We can have an agent look over these, right? So we can have all kinds of systems here that actually make the RAG a lot better. So this is something that we can do next time if this is also something that people are interested in. We can use something called Langflow for that. Langflow low code. So it says low code. I think you can get quite far with no code, but it does say low code, right? So, is there anyone that has heard of Langflow before, right? So just checking. Has anyone used Langflow? Probably maybe LangChain is maybe more familiar, but it is made by the same people, I think, from LangChain. Is there anyone that's done Langflow before? All right, so as you can see, it's very low code or basically no code. You get these blocks where you can get maybe some input. You choose your model. You have to provide an API key, of course, right? And then you will get some output basically. And you can just wire them together. So they have like nodes that you can connect to. And so this is how you can make your little agents, right? So you can have one node that is just this model, and then you can have like a summarizing model, right? So agent, chat input, right? So this is how they kind of show you. It has like an input, and then it has maybe some outputs, for example. And you can control it quite easily. So we can go into this next time. It's a little bit more advanced, let's say, than just using Open Web UI, but it allows you basically. Sorry for the flashbang, by the way. I should give people a heads up if I'm planning to show a bright white screen. But yeah, so essentially this is an accessible way to get into more agentified AI, but still, of course, it's not like a complete end-to-end solution, right? So I can only help building the background intuition and helping getting started with maybe some prototyping, but I cannot teach you how to make like a real end-to-end software solution. You can ask LLMs to do that for you, or to at least guide you through that. but you'll be oblivious to any potential security issues, and you'll have to trust it when it says something is secure or not, which is typically not a very good idea. Right, so we can get into why that is not a super good idea. So let's first look at like maybe some of the horror stories, and then we will get back into maybe why we still want to do this or not. So yeah, let's try that, I guess. One of the ones that I think was quite prominent. Flashbang warning, maybe too late. Was from Meta Safety Alignment Head email deleted. So this is one of the stories, right? So OpenClaw. So this is one of the agentified sandbox AIs that we will be that I'll be showing in 5 minutes. And yeah, I mean, she admitted it's basically a rookie mistake, right? So the Meta Director of AI Safety allows an AI agent to accidentally delete her inbox. I mean, this is really what was just going on. So she had installed the OpenClaw, and she told the AI agent to go through her email box and clean up if necessary. And essentially, she told the model, please confirm before acting, right? So that was what she told it. But of course, these models sometimes do things even without confirmation, because if they can do it, they may do it, right? So these things are not deterministic; they may do it. And so it deleted. I think it deleted in the end. It deleted like 800 or something emails, so well over 200 if I remember correctly. So yeah, these models have been known to do things on their own if they can. And actually, a more recent example coming from, so as you can see, this is actually not that long ago. This is like, you see this is like less than a month ago, right? Pocket OS, I don't know what they do exactly, but essentially they have clients, and each client has a database managed by Pocket OS. And so without that database, their clients cannot function. And hilariously, or well, not so hilarious, I guess, to the CEO and owners of that company, of Pocket OS, but I guess it's interesting to anyone else. Pocket OS had their AI agent delete their entire company database. And so this happened also because actually the AI agent did not have access to do anything, right? So the AI agent did not have any permissions except for maybe coding and maybe checking if the code was running properly, right? So it had maybe some basic terminal commands that it could use, but it definitely did not have permission to access the database or to override it. But then what actually happened in this story, right? So you can read for yourself if you want to find out more. But what happened in a nutshell is that essentially the AI agent found in the code base an authentication token to connect to the database, and it wrote some code using that token to wipe the database, because actually the AI agent was finding that the code it had written was not working with the database. And so instead of writing better code, it was thinking, oh, maybe I will just clean up the database a little bit instead, like make it fit my code instead. That'll be easier than writing better code. So this is another like little bit of a horror story, I guess. I don't know if people saw this one. I think people saw the one from Meta, but I don't know if everyone saw the one from Pocket OS. Yep. So this is then I guess a word of warning before we get started, and this is also, I guess, why I'm really stressing the safety implications of this. It should really be noted that if you decide to follow along, please be careful with where you're running it and what you're doing. If you have passwords in text files lying around that the agent has access to, it could be sending this to somewhere, right? Like you don't know where it's going to be sending this. If you have old photos that you don't want to lose, don't give the AI agent access to that, right? Not even by accident. So what we'll be doing is we'll also be setting up an AI agent, a little bit like OpenClaw, right? So if you remember from last time, essentially I was showing how we could host our own model. Olama is an easy way to do it, but there are many other ways, right? So essentially all this is doing is that you have the LLM, right? So you have this big block of weights that get passed forward, right? So this is all the maths that maybe you don't necessarily understand. But either way, we have this. Now you need to have a way to get user input chat in a format that the LLM will accept, and then get that back out in a format that the user can read, right? The output from the LLM. And this is what then the Olama or whatever is hosting your LLM will take care of, right? So you don't actually have to load in the weights yourself. It takes care of downloading it if you don't already have it. So you have all of these kind of benefits, let's say, alongside of getting the model to actually download it and run. But then you can do much more. You can also actually immediately use OpenClaw from Olama, right? So they have OpenClaw. You can have Claude Code. You can have OpenAI's Codex, OpenCode, which is, if I understand correctly, OpenCode is essentially like a more open version of OpenClaw. Hermes from Nous, right? So we know these, or at least I know that some of us know these. And finally, I guess the one that I'll be looking at today, there's a few more, but the one I want to look at today is Pi. Copilot, of course, everyone knows Copilot, but I want to look at Pi, which is like a very minimal AI agent toolkit. Essentially, it leaves the responsibility to you, and I think that's both a good and a bad thing. If you're not going to do anything, maybe OpenClaw has some guardrails, right? So it's instructed not to delete your entire operating system. But also, it's not like guaranteed, right? So there's no guarantees here. And so actually, I prefer kind of being upfront about no guarantees, but you can extend it however you like, right? So let's have a look at what Pi looks like. Dev. Their website is, of course, very fancy, right? So very nice for them. If I scroll, it looks very smooth like this, right? So it's very cool. The only thing I really care about is that I want to be able to install it, right? So it's not super easy to install on Windows per se, I don't think. But there is something that I find even more important than just the agent, right? So again, all of these are kind of the same. They are these sandboxed AI agents, right? So they are LLMs, plus they can do a lot more, right? So they are LLMs, plus they have ways to actually interact with your file system. They have ways to run code, for example. They have ways to search, right? So this is all of what's going on there. And Pi is just one of them, right? So if you're used to Copilot, if you're used to OpenClaw or Claude Code, then Pi is just one of these. But it's a little bit more simplistic, I guess. But it's also very extensible. And so one of the extensions is Pi less YOLO. Pi less YOLO. You have to love the naming senses that these people have, right? So it's less YOLO. Why is it less YOLO? Well, it's less YOLO because there's no YOLO. You're never going to get like completely safe AI. Container escapes exists. So what a less YOLO does, it runs the agent inside its own container, right? So even if it tries to nuke its own operating system, the agent that you're putting behind it, so it could be Claude, could be OpenAI's ChatGPT, could be Gemini, whatever LLM you decide to put in here, if it decides to go wild, if it decides to go amok, then you're still fine. It has only nuked your container and not actually anything that you care about. So you just close the container and restart it and you'll be fine. So that's why it's a little bit safer. It's still not completely safe, of course, because, as they say, container escapes do exist. Moreover, very often for them to be useful, you actually want to get their output into your own local files, right? So that means it can write to your files, at least maybe within one limited folder. But maybe it can find, if you have some tokens there, or if you have some stuff there that you don't want to lose, maybe that's already unsafe. But also maybe it will be able to connect to other services, right? So if it has like a web exposure and it is like containing some sensitive information about you or from you, then that could be leaked as well. So always be careful with that, and just like really nail down, hammer down also in your own mind that you're trying to give this the least amount of privileges, right? So the least amount of access that you can basically give it. So this, I'll be showing this essentially, and you'll need Mies for this, and Docker or Podman. I have found that the setup does not really work nicely on Windows, right? So as you can see, I'm on Windows. You'll want to use Windows subsystem for Linux for this if you want to do this. There is ways to set this up. You can let me know in the generative general chat if you're trying to set this up for yourself later on, after this video is over or after this session is over. And if you run into any issues, I can help you with that, of course. But for now, I'm just going to skip over it to be able to show you what actually it looks like. So we have a model running through Olama, and then I will set up Pi, so it's like here, right? So let's just get out of here. No, actually, yes. Yeah, so here I'm in Windows subsystem for Linux, so that looks a little bit like I just go to CMD, right? So command prompt or terminal on Linux. And then to actually go into Linux, I write something like WSL, right? So this is essentially how I'm going to be able to start the agent. Hello for the late joiners. I'm going to be starting the agent like this, and then I'm going to go to a directory that I wanted to have access to, so in this case the test project, and I will just do something like mis run pi, that's all. And I'm also going to tell it that it can use local models, right? So it can use Olama. And then you will get greeted by something like, so I have already done this before the session, so we don't have to wait for it. I'll show you what it looks like live later on as well. But basically there's an LLM, there was an LLM running, it was Gemma 4 26 billion. You can run this locally, I'm quite sure. If you have like an RTX 3080, if you need if you have RTX 4070 maybe already, and for sure you can run the smaller models, right? Like the E4B is meant to be run on like on your phone or something like this, right? So it's like for sure you can run this. Whether it's good, I'll let you be the judge of this. This is the 26 billion one, so it's like the second largest. It's not a bad one. It's not a super good one, but it's not a bad one. So essentially, I'm saying an absolute newbie came in here and wrote the code that you can see here, right? So it's like the code that you can see in here. It's like these things. Please clean it up. Now, this code was not written by an absolute newbie. It was actually written by another LLM. Then it will start thinking, right? So it starts thinking. So it's these thinking tokens that flashbang incoming. The thinking tokens are very similar to what you have here, right? Basically, it's just the same. It's just shown in a different interface. And these are all the thinking tokens for a very long time, right? So it's just a little bit of nice formatting, which makes the scripts render as scripts, but they are all like thinking tokens. Okay, so they think to themselves, the user wants me to clean up some code, but they haven't provided the code in the prompt or the file path in case that I included any files with it, for example, right? So I need to find where the code is located. I'll start by listing the files in the current directory. So I didn't give it anything, but this LLM is able to run ls command, which basically is going to show it which files exist, right? So this LLM is now interfacing with my machine through the container, basically. Okay, and then it will just go off, it will just read them, most likely place for the code between quotation marks. I like that it put it between quotation marks, you know, maybe it's not even code, you know, it's like vibe coded. It could be anything. It could be spaghetti, it could be vomit. We call it code. All right. So it's calling calling them out. Perfect. Okay, I see what's happening. Actually, let's look at what the code does. Wait, if the user wants random movement, right? So it's really second guessing itself, and basically, what this code does, it showed hello world, right? So it just showed hello world on like a HTML web page. Okay. Now I'm going to be going quickly through this, but basically I want to point out a few things that is interesting. It's really second guessing itself quite often. Let me find another nice example. Really large strings of text, you know. So I was making some changes. I noticed a mistake in my write call. I accidentally included some HTML like closing tag, so it just inserted this randomly without properly closing it, right? So it's like writing buggy code, all kinds of things. This model that I'm running locally is not going to be a super good model for programming, right? So you'll probably want to use an external model for this, but again, if you're using an external model, who knows what information you could be sending to Claude, so Anthropic or OpenAI, right? So it's always a trade-off between a small model. If you have a question, please just type in chat. At the moment, it's a bit quiet here, but essentially, this session is being recorded. The recording will not see the chat, so if you have a question, I will repeat it where relevant. Yep. So thank you for understanding. Sometimes these sessions can be a bit more busy, so it's nice to keep things streamlined that way. And this way, there can also be a chat happening in the background while I continue speaking, right? So it helps keep the pacing for this session a bit on track. Yeah, so we have that, and so the model really like it second guesses itself, introduces some typos or mistakes. At one point, basically, it's supposed to make the hello world bounce, right? Basically, but at some point it stopped talking about start bouncing and it started talking about start banning. I don't know where it got the start banning from, right? So is there someone who has maybe some thoughts as to why this model could suddenly start talking about start banning? So why did some accidentally make this start banning typo? Some ideas in chat? Some thoughts? Did I tell it to be a benevolent moderator? Is that why it wants to start banning? It does know it's still talking about bouncing though, actually. So any ideas why this typo, where it might come from? I mean, your guess is as good as mine, to be honest. Here, like, you never really know exactly why it's happening, but we can speculate a little bit, right? So, any thoughts why the LLM that was supposed to be talking about start bouncing actually is now start banning? No thoughts. No thoughts. Head empty. All right. So feel free to put it in chat if you still have some ideas after. But for now, I'll just continue. So yeah, here it really likes what it's doing, and then you can see all set. I'll provide the final response. I'm ready. Everything looks good. Perfect. I'm done. Oh dear, and it just keeps going this loop, right? So local LLMs are not always the best ones, unfortunately. So we can look at what that looks like, right? So here we go. Hey, can you describe what's in this project? Use ls. right? So, and also because it's local, it's depending on your hardware. And so if you don't have super good hardware, it will take some time, right? So there it's the thinking tokens again. You can configure it to show or not show the thinking, right? So we can collapse it, as you can see. But for now, let's keep an eye on what it's thinking about. And while it's doing this, let's just let it keep doing this in the background. We can talk about maybe what else it can do, right? So as you can see here, it can run ls, and you can very easily extend it. And you can also, if you have a good model, and not the one I'm hosting locally, but if you actually have a good model tied into this, you can also give it new tools to play with, right? So now it has the ls tool, which lists the local files, but let's say you can also give it maybe a way to search YouTube, right? Or maybe to transcribe a YouTube video, to get information from YouTube videos. This way you don't have to watch the YouTube video yourself for the full thing. You can just get the AI to transcribe it, and then after it's been transcribed, tell you where in the video, for example, maybe a certain thing gets mentioned, right? So this is a nice way to do that. If you give it tools for that. Yeah, so then finally in the brighter white, it will actually say this project is a simple interactive web application called Bouncing Hello, right? So this is essentially the output. And I can show you what that looks like, but you'll be blinded by a white screen again. It looks a little bit like this, right? So it's the file here. So the file is on my machine. I don't know if there was a question in chat or a message in chat. But yeah, this is the thing that was on screen. Go ahead and type it out. I'll get to it when we get there. But there is like this thing that got shown. This is all vibe coded basically, and when you click it, this is what happens, right? So it's very cute. And if you click it faster, it will cycle through the colors faster. Very nice. So this is basically what just was generated by the thing. So the question is in chat: is there any way to actually prevent this stupid doom loop where it will just keep thinking itself from happening when you're using a small AI model without increasing like the model size, right? So you get like a larger model, of course, that typically solves it. If you get a larger context window, sometimes that can help a little bit. Not necessarily. Sometimes it can actually make things worse. So how do we overcome this this thing here? Well, actually, it ties a little bit back to the question that I had about the start banning thing here, right? Maybe what it can sample from the temperature is a little bit too high, which means that it can actually sample random words sometimes that are not actually helpful. And maybe if you're able to constrain it, I think there's a way, if you self-host it, I think there's a way to make it a little bit more constrained in which tokens it can sample from. Then it's a little bit more deterministic, a little bit more, and maybe it stops earlier as well, right? So then it doesn't get into this loop. It actually figures out what to do. The issue is that once it gets into a loop, right, this then it's basically getting into a space where it has maybe 100 examples of itself second guessing itself. And so the logical next thing is it going to stop at 101 or is it going to second guess itself, right? So this is why actually after 100 times of second guessing itself, it will second guess itself again for the 101st time and for the 102nd time, right? So this is kind of why it kind of stays stuck in this loop, or at least that's kind of how I think about it. Another thing that you can do, of course, is that if you're doing it a little bit more like this, in the case of like agentic AI, where you're building multiple agents, you can have, let's say you have your a little bit more expensive model, maybe that you're hosting locally, that does all of the writing, but maybe it is going off, on, off, and off, and it's like writing a lot of nonsense. you can have a small, if you don't want to be the one yourself that is there all the time, you can of course just put a context limit on it, right? So like, first of all, you can just say, if it tries to exceed this amount, I will throw away everything and try again, right? So typically, if you try again, it will not just happen again. Like typically, if you try again, there is a good chance that I will not get stuck in the exact same loop. Although small models may get stuck in loops much more frequently than the larger, better ones, right? So that's the first one. The second one is to essentially insert breakpoints where after every so many lines, you send this off to an evaluator, right? So this is maybe a different agent, which is just another small LLM, and it decides, okay, has it been sufficiently answered, yes or no? If it has not been answered sufficiently yet, keep going, and we do the next one. And if it has been sufficiently answered, then try to summarize, right? So we get another one, summarize, and then actually give it to the user. So then it actually goes into the chat for the user. So this is another way to do it as well, if you're modeling your workflow with agents. And this is a bit nicer, I think, if you have your own hosted agents. It's not so expensive to do this. Of course, if it has to be an external call, you're introducing a lot of latency. If this is like Google Gemini, right? So if it's like Gemini, then maybe it's not really worthwhile to do that. Gemini. Okay. I hope that answers the question a little bit. It's not perfect, right? So these small models will do it more frequently, and there's not really a way to get out guaranteed. But there's ways to detect it, right? And there's ways to brute force it to stop, and to kind of be a little bit more elegant, let's say, in when you stop it or not. And the agent can be instructed to also detect these kind of loops, right? So like if it's like really saying almost the same thing again and again, these agents can be instructed to that. Okay, so I hope that answers it a little bit. Yeah, it's not perfect. I mean, you can do a lot of things, right? So you can also just detect how similar these outputs are from before, right? So if in its thinking tokens, the outputs are very similar, like if it's really just repeats, then you can detect it. But if they are like what was happening here, it's harder to detect, right? So like if it is something like this, I think the current code is good, one final check, wait, so it works, one minor thing. In this case, the it's really rephrasing itself all the time, and then it's really hard to kind of detect this automatically. Okay. Yeah, so here we have one example. Another thing is that you can be a lot more secure about this, right? So maybe there are some tools that now have web access. I don't know if this thing will get web access or not, but basically you can tell where this model runs in the container. You can also actually tell it to not have any web access. Then if it's programming in something that wants external libraries or external tools, it may want to try to download it. You can do something like having a local gateway, essentially, right? So you have the LLM, which is like some AI, which is maybe changing some files. It is writing some code, very nice code, beautiful code. Oh, I want to have, for this one specifically, I want to have a certain library, right? The library does not exist within the really like the closed off bubble that the AI agent lives in. And so we need to have a way to actually bring in some libraries, basically, so you can have a little program running. We call this, like, let's say a gateway, like gateway. Can we make that a little bit bigger? Yeah, there we go. And then the request will go to the gateway, and if it's like a normal request from libraries that we know and we trust, basically, then we can actually make that go to the internet, or if it's like a Google search, for example, we can make that go to the internet, right? So here's like the World Wide Web, and then we get the result back and we give that back, basically, right? But if it's something that we should block, right? So maybe it's trying to send your passwords, maybe it's trying to send them somewhere, or maybe it's trying to access your local machine and try to delete your emails, then of course it is immediately rejected, right? So it never goes here. It's immediately rejected, and it's told, no, you cannot do this. Of course, if it's trying to use a library that you want to accept, you will then have to change this cross into a check, right? So you want to actually allow it through the next time, and then you tell it to rerun it. So it's like, go ahead, please. You can rerun it, and now you will actually get the correct library. So these are some ways you can do to make the Sandboxed AI a little bit more secure. Of course, it's never perfectly safe, but really it's a lot safer to have it have almost no access to anything and do only a few things that you're interested in, like maybe build a little website, maybe you can write it some code, help it write some code. If you're learning something, if you're writing a book, for example, maybe you have all your document snippets here, right? So it's like what language is this? New text document with a K. What? Okay. So you have maybe your backstory for some character, for example, right? And you want to have it be a collaborative writing assistant. John is a super cool AI agent, and there we go. Now we also ask it like, hey, I added a.txt with some backstory, please complete it. There we go, right? So basically we can just also ask it to do that. And we can do all these kinds of cool things that we can use now instead of going to, let's say, Claude in the interface, or going to chatgpt.com instead of doing all these things. Now you actually have it given access to your files. You can have it given access to Google. You can have it given access to a lot of different things that are relevant for your specific project, right? So that's also a really nice thing. By having it only given access to only the most relevant things, it's more likely to actually focus on the things that matter, and you don't need an as big model. Of course, small models will still probably mess up, but you may not need an as big model as that you need when it has everything, right? So like if it is this tool and it has that tool and has that tool, when it gets a million things that it can do, it becomes a little bit harder for the AI to decide the most effective way of doing something. Okay, so we have a few more minutes. We can wrap up a little bit early, but of course, I'm also happy to answer some questions if there are any about this topic, right? So we have seen how we can host it, right? So like if we have Olama, we can very easily make a new chat and we can download all these models, right? So these are automatically downloaded. If we chat something, it will start downloading it, right? So this is very nice, and it's immediately exposed on your machine, just only on your machine. You can also connect to external vendors, which I showed in last session a little bit. And then we showed how we can get an AI agent that is able to use some tools like LS, right? So like looking at your files, it has read, it has write. So it has like all these different tools, and you can give it more tools, right? You can make it safe. You can put it in a bubble, really closed off in its own container, so that it will not actually be able to see all of your files, only the one in the folder that it's currently running in. So I hope that was interesting. Of course, if you're watching this back later and you're trying to set this up for yourself and you're running into anything, please don't hesitate to reach out in chat, in Generative General, or in Quick Questions. There is a few more minutes if you want to ask some questions now, if you want to see something cool. You're probably wondering maybe what the LLM wrote, right? So maybe it added something. Backstory, it's been changed, it's been modified. There we go. John is a super cool AI agent and he loves playing with colorful bouncing web animations. That is truly inspiring. And I love that the LLM added that, right? So this really is some collaborative writing going on there. I'm so glad I have this local model running locally. We can also try looking at different models. So I have, I think, configured a few other models. So we have Gemini 2.5. So it's like, can you have the hello world text follow the cursor? Right, so we can do something like this. And as you can see, it is so much faster, right? It is so much faster than hosting something like this yourself. This is, of course, one of Google's smaller models, all right? So one of their older models as well. This is a free one. Their paid ones are much better, right? So, of course, if you have any serious business, you'll want to pay for it, in theory, if you support that kind of stuff. But yeah, they have made some changes that for sure the locally hosted one could not have made. Let's have a look at what happened. Right, so this is what we had before. Very inspiring. And this is what we have now. Okay. All right, so it is working. And can I still click it? I can no longer click it. I don't have the click functionality anymore. Right, so... Oh, okay, so we do have a little bit... If I'm fast enough, it follows it like a little bit slow with some lag. You can still click it. So very charming, and yeah, you can build a lot of cool things, of course, with this, but you have to be super careful. If you don't know about web hosting, you're going to have to be careful with trusting it on how to put things live. I don't think you should trust it. I think you should first learn for yourself which things need to be done in which way for them to be safe, and only then you should trust the actual AI to do it for you and inspect and be able to inspect essentially what it's doing. If you don't know what it's doing, you can't inspect whether what it's doing is actually safe or not. So one recommendation is in chat is to put your API keys and tokens and passwords. If you're doing a programming task, put them in a file called .gitignore, right? So this is very good advice because Git ignores it, and Git is this place where you can host your code. And so, of course, you don't want your passwords to be hosted with your code, and so you put it in the .gitignore. But actually, this guy is gaslighting you. Don't trust him. Don't actually put it in the .gitignore. All right, that's it for today. I will be closing off the... Yeah, as in inside the file itself. Yeah, exactly. Don't do that, right? So obviously, the .gitignore specifies which files should be ignored, and so it's more like a file specification. All the names that you put in there are going to be put on the online repository as well. So this is if you put like someone's asking for a link. I don't think there is a specific link for that. The link is github.com. All right. Okay. Well, I'm closing the recording now. I'll be around for a little bit longer in case there are some questions. If any of you are watching this at a later point in time and have questions, please don't hesitate to ask. I'll be able to answer. At least I'll be able to answer, but whether the answer is useful to you, of course, remains to be seen. Bye-bye.